Friends, basically we are familiar with 4 operations, namely addition, subtraction, multiplication and division. These operations help us to establish relationships between numbers. Today, we will discuss operations on real numbers and some identities. Friends, we have learned that rational numbers satisfy the commutative, associative and distributive properties for addition and multiplication. Friends, if we add, subtract or multiply any 2 or more rational numbers, then the resultant number is also a rational number. Can we say the same for division also? Let us see. Here are 2 rational numbers. When we divide them, we will still get a rational number. Please notice here, in place of 2 by 3, if we keep 0 and then divide it by 3 by 2, we will get 0, which is a rational number. But now, if we replace 3 by 2 by 0 and divide 2 by 3 by 0, we will get a number which is undefined, or say that it isn't a rational number. Therefore, we can say that rational numbers are not closed under division, but if we consider a set of non-zero rational numbers, then that set will be closed under division. Irrational numbers also follow the commutative, associative and distributive rules of addition and multiplication. But on adding, subtracting, multiplying and dividing irrational numbers, the number so obtained is not always an irrational number. That means irrational numbers are not closed under these operations. Friends, you can easily understand the same by looking at these examples. Here, we are getting both rational and irrational numbers. Friends, all these facts are true for operations between same type of numbers. Now let's learn these operations between rational and irrational numbers. 4 is the rational number and root 19 is an irrational number. Can you tell on adding the two, will we be getting a rational number or an irrational number? The decimal form of root 19 is non-terminating, non-recurring. Therefore, the decimal form of 4 plus root 19 will also be non-terminating, non-recurring. That means this is an irrational number. Friends, let's try it for subtraction. Root 6 minus 3 will be irrational number since root 6 is an irrational number. On multiplying 2 with root 5, we will get 2 root 5, which is also an irrational number. Now let's do the same for division. Root 17 is an irrational number. Its decimal form is non-terminating, non-recurring. On dividing the same by 4, we will get root 17 by 4, whose decimal form will also be non-terminating, non-recurring. That means it is an irrational number. After seeing all these examples, we can conclude that the number so obtained on adding and subtracting a rational number with an irrational number will be an irrational number. Similarly, the number obtained by multiplying and dividing an irrational number with a non-zero rational number will also be an irrational number. Let's move ahead. Consider if a and b are positive real numbers, then root ab will be equal to root a multiplied by root b. Similarly, root a by b will be equal to root a by root b. Friends, you're familiar with these 2 identities. Here, a and b are real numbers. Now if we replace a by root a and b by root b in the first identity, we will get this. And here, if we keep a as it is and replace b by root b, we will get this. Now, if we do the same process with the second identity, we will get root a square plus 2 root a root b plus root b square. And here, root a multiplied by root b will become root ab. And now we will finally get a plus 2 root ab plus b. Now, suppose if the numbers are this way, root a plus root b, root c plus root d, then what will we do? Let us also simplify this and see what we get. Here we will simplify just like how we open the bracket for any multiplication operation and then add the terms. Or say we will use the distributive law of multiplication over addition. Now we will get root AC plus root AD plus root BC plus root BD. All these identities related to square root are useful in different ways. In the next video, we will discuss them in detail. That's all in this session. In this video, we discussed operations on real numbers and some identities. Thank you. Now we will solve some questions using operations on real numbers. Let's start with the first question. Identify rational and irrational numbers from the given numbers. Friends, in the first number, root of 11 is an irrational number. Its decimal expansion is non-terminating, non-recurring. Even if we add 7 to it, its decimal expansion will be non-terminating, non-recurring. So it is an irrational number. The second number is pi by 3. We know that pi is an irrational number and its decimal expansion is non-terminating, non-recurring. Even if it is divided by 3, it will be non-terminating, non-recurring, which means it is also an irrational number. Friends, in the third question, root 3 is an irrational number. But here, the numerator and the denominator both have square roots of 3. Hence, we can cancel the square roots of 3 and get 11 by 2. This is a rational number. Now let's take the last question. Here, by subtracting root 5 out of 2 root 5, we get root 5. And this is an irrational number. Friends, let's solve one more question. Simplify these expressions. Friends, see the first expression. This looks like the identity a plus root b, a minus root b. Here, a is equal to 8 and b is equal to 23. So let us use this identity a plus root b, a minus root b is equal to a square minus b to solve it. After solving, the answer is 41. Friends, now look at the second expression. This looks like the identity root a plus root b square is equal to a plus 2 root ab plus b. Here, a is equal to 2 and b is equal to 3. We can solve this easily using this identity. Now let's take the next expression. 6 plus root 5, 2 plus root 3. In this expression, we will use the identity root a plus root b, root c plus root d is equal to root ac plus root ad plus root bc plus root bd. It is very easy. Pause the video and try to solve it yourself and see if you're getting the same answer. Now let's take the last expression. This identity is in the form of root a plus root b, root a minus root b is equal to a minus b. Solve it yourself. So friends, that's all in today's session. In this session, we solved some questions using operations on real numbers. See you in the next video with some facts related to this. Thank you. In this video, we will discuss some facts related to operations on real numbers. Let's start. Choose the correct option from the following. Friends, look at option A. Here, the rule root of a into b is equal to root of a into root of b has been used. Now let's find their value and check. Here, the value of root of 15 is equal to root of 5 into root of 3. Therefore, this option is correct. Now look at option B. Here we will use this rule, root of a by b is equal to root of a by root of b. Here a is equal to 5 and b is equal to 3. Let us find the value of root of 5 by 3 and the root of 5 by root of 3. The values of both are equal, so this option is also correct. Let us repeat the same process in option C and find the values to check. You can see the value of root of 8 is not equal to the value of root of 5 plus root of 3. Therefore, this option is incorrect. Now look at the fourth and the last option. Here also, the value of root of 2 is not equal to the value of root of 5 minus root of 3. This means that this option is also wrong. Real numbers are closed under addition, subtraction, multiplication and division. Friends, tell whether the given statement is true. We have studied about the closure properties of both rational and irrational numbers. Now let's take some examples and see whether real numbers follow the same or not. Here are the two real numbers. On adding the two, we get a real number. Similarly, on subtracting or multiplying two real numbers, we will get a real number only. Now let's try for division. 2 and 6 both are real numbers. On dividing the 2, we get 1 by 3, which is also a real number. Friends, now in the place of 2, if we keep 0 and divide it by 6, we get 0, which is also a real number. But if we take 0 instead of 6 and divide 2 by 0, then the number we get is undefined. This means here we did not get a real number. So is the given statement correct? Think about it and confirm your answer. So friends, that's all in today's session. In this session, we discussed some facts related to operations on real numbers. See you in the next video. Thank you.